Hello class, we can now go to activity number 2. We are moving from activity 1, now activity number 2, and the question was talking about electrolysis of aqueous copper 2 sulphate. When you are dealing with aqueous copper 2 sulphate questions, they specify the type of electrodes you are using. So here it says using inert electrodes. Sometimes they say using copper electrodes. Now here they are saying using inert electrodes. Inert electrodes could either be platinum or carbon in form of graphite. So we are dealing with inert electrodes for now. In my next video, I'll talk about electrolysis of aqueous copper 2 sulphate using copper electrodes. But for now, let's go inert electrodes. That's what we are dealing with. And now the first question was question A1. It was saying name the ions present. In the aqueous copper 2 sulphate, we have copper ion and a sulphate ion. Now, because there is also water, it means there will be hydrogen ion and hydroxide ion. So now, the hydroxide ion, there is copper 2 ion, hydrogen ion, sulphate ion, and hydroxide ion. So all the positive ions, copper 2 ion and hydrogen, they will migrate to the negative electrode, which is the cathode. Then the sulphate ion and the hydroxide ion, they will be attracted or migrate to the positive ion, which is the anode. So when the sulphate and the hydroxide come this side, the one which is lower in the electrochemical series is preferentially discharged to the other. In this case, the hydroxide is preferentially discharged and forms water plus oxygen plus electrons. When we balance it, it forms 4 electrons. Okay, so this is the equation which will take place at the anode. There is an equation on question A2. It says write down the equations for the reactions occurring at each electrode. So at the anode, this is the equation. Let's go to the cathode. You know, at the cathode, you expect to have you expect to have hydrogen ion and the copper 2 ion. So in that case, the equation will be, we'll consider the copper 2 ion, because when you follow the electrochemical series, even the reactivity series, usually copper is lower than hydrogen. So we are going to follow the copper. You know, this is a cation. For it to become a cation like this, it means that it gained 2 electrons. Now, for it to form the copper metal, it's supposed to gain its electrons which were lost and form copper metal. Okay, so we have written the equations. That is answering question A2. At the cathode, copper 2 ion gains 2 electrons, form copper metal. At the anode, you have now the hydroxide ion being forming 4 electrons, oxygen and water. Okay, so that is the other part. So for now, question part 3 says explain why copper, not hydrogen, is discharged at the cathode. Why copper and not hydrogen is discharged? So the reason is that copper 2 ion is lower than hydrogen in the electrochemical series. So the one which is preferentially discharged is the one which is lower than the other. The one which is higher is not easily discharged. So that's the reason. For now, let's watch the next video, which will be tackling question A4, which says calculate the volume of the oxygen gas measured at room temperature and the pressure formed at the anode. For now, goodbye.